It's really freaky. Whee! Is it zoomed in? Freakiness. Oh, yeah. There you go. All right. So, let's see. Well, how about this? I don't know if you guys have tried it out yet. Number 2 in the practice final. All right, so if you already tried that, just hang out for a second. If you haven't tried that yet, try that now. Everybody's got one of these, right? Seems like a useful thing.
I'll never know how to do this. Something that
Part of it is because people read through it and you expect, for some reason, that you're supposed to be able to set everything up immediately. That is insanity. The first thing you do is not math at all. It's just, what are the players involved? You don't care about the numbers. You don't care about the 5 more than. You don't care about any of that shit. The first thing you do is, what are the players? Who are the things that have English names that need to be given math names? That's the first step. Make sure everybody's on the right track. Just to give you an example. When I read through this, I read one side of a triangle, smallest. The largest side, smallest. Okay, now I got my 3. I don't care about the blue crap. That's math stuff. That's the next step. The first step, so I got one side. Bam. I got smallest side. Bam. And then I got largest side. Bam. Now I start to think about math, because I have to. Eventually it's going to be math. These are the English names. I got to give them math names. Somebody is almost always going to be just X. So which one do the other 2 depend on? Smallest. Everybody depends on the smallest. The largest and the one side are something to do with the smallest side. I have to give him a name first. So yeah, normally we use X. I like it. To be honest, you can use any letter you want to. Now you start to bring in, to get the names for the other 2, you want to bring in the relationships. And they are mathematical relationships. One side is 3 less than twice the smallest. So this is the next place people make mistakes. 3 less than twice the smallest. Well, what's twice the smallest? And what's 3 less than that? Yeah, so twice the smallest, 3 less than twice the smallest. The mistake people make is they write 3 minus 2x, because they just write it as they see it, instead of realizing the English grammar for that doesn't work that way. Largest is 5 more than 3 times the smallest. More than, you can't go wrong. 3 times the smallest, and then 5 more than that. Cool. See, now that you've given the English, you've given the math names, that captures their relationships. Now you can use these to get how they all 3 work together. What do all 3 of them do? Make a triangle that has a...
62.
Yeah, they have to add it to 62 because they make a triangle with a perimeter of 62 inches. So now you have to add these up, because that's how you get the perimeter. And it has to make 62. So you just write it and then you solve it. There's nothing really to try to do in your head. So how many parts will the answer have? 3, because there's 3 sides I don't know. So when you add all these together, you get 6x plus 2, and then it has to be 62. So then this is nice. You subtract 2, you get 60, you divide by 6, you get 10. So what's 10? Small. Smallest is 10. 10 what? Inches. 11. And then what's the one side has to be twice 10 minus 3. 17 inches. And the largest got to be 3 times 10, 30 plus 5. 35 inches. And how do you check it? Yeah, all 3 of these are supposed to make 62. When you add them, they do. I like it. So let me do this something I don't do very often, but the one reason I don't do this too often is because this isn't what happens in the real world. This has an application in the real world. I don't care what you think. It doesn't matter what you think. It does. So we have to be able to model stuff mathematically so then we can use an equation to solve what's going to happen. But how do I make a problem so it's going to work? If I just make shit up, is it going to come out nice necessarily? Probably not. So how the hell do I make a problem? Well, let me see. Give me some sides. Like this longest side, how long do you want it to be?
Just a numerical value?
Yep, give me a number.
7.
7 feet, let's say.
Yeah.
Right? So then let's make sense for this side then. 5, I like it. And then what about this side? 3, I like it. Now, so go with me. I'm showing you something I don't normally show, but it's maybe it'll be good to see how I make a word problem that will work nice. I know the answers are going to be 3, 5, 7. So now, what relationships do you see between the sides? For example, and what do you want to relate everybody to? You don't have to relate them to the smallest. Let's relate them to the middle side. So the largest, how do I get it from the middle? What do I do? Yeah, I could add 2. I could, twice this is, twice this is 10 minus 3 is 7. Do you see? 3 times this is 15 minus 8 is 7. There's an infinite number of little relationships I can make. Let me stop there for a second. Do you guys see that? So I got concrete numbers for myself, and I'm seeing how are they related. So the simplest relationship between these two is that's twice, 2 more than that. So that works. So let's say the largest is 2 more than the middle. Right, which is true. 5 plus 2 equals 7. Yay. And then the smallest is
4 times less than the large.
well, what are we basing everything on?
Oh,
The middle.
sorry. Yeah.
So the smallest is going to be 2 less than the middle. So then I can give somebody, there's a triangle whose perimeter is 15, where the largest side is 2 more than the middle, and the smallest side is 2 less than the middle. There's a problem I can give you, and you know it's going to have nice answers because we started with the answer. Now, obviously, this ain't what happens in the real world. We don't start with the answer in the real world. But to make a problem that's going to work nice so you can get used to how algebra works, that's how I can do it. Now, real quick, I want you to notice something. What if I made the middle... What if I made the middle side 11? And I follow these same relationships. The largest is 2 more than the middle. What would the largest be? And the smallest would be 9. So how many triangles do these two statements, how many triangles do they define? An infinite number. Bless you. Because if I change where the middle number is, then it changes the largest and the smallest, right? All right, so when I set up my equation, I really want you to this to make sense. So if I have the middle side is x, the middle side is x, this would be, the largest side would be x plus 2, and the smallest side would be x minus 2. There are an infinite number of triangles that follow those relationships, because for every value of x, of course it has to be a number bigger than 2. Can you guys see why? X can't be less than 2. Actually can't even really be 2, because then the poor smallest side is 0. That doesn't make any sense. All right, but that's a side note. Every value of x that I pick has a different triangle, and they would all have different perimeters, wouldn't they? But there's only one triangle that does this with a perimeter of 15. So when you set the equation up, you're saying, okay, the perimeter of all of these triangles is this. I want the triangle that makes it 15. That's what you do when you make the equation. You're saying which specific thing makes 15 happen in this case. What would it be for this triangle? It would be 33. The perimeter would be 33. If I put a 33 there, x would be 11. Because x is the middle side. Okay, I pushed that a little bit further than you're used to, but what the shit? That's fine. I want you to see the whole idea, right? Because people make so much of these word problems, and I understand you're not used to them. That's why you hate them. But what they're trying to do is they're trying to model the relationships, and then when you set it equal to something, you're saying, I want the specific one where this happens. Now 2b, you got the setup, but then you end up with kind of a gross thing to factor. So evil. So here in English are the players in this problem, right? The length and the width of this rectangle. Which one's going to be just a letter? The width, right? So use W, we'll use X. Just keep it straight up the same thing. The length is 2 more than 3 times that, so that the length is 3x plus 2. And the area of this rectangle is supposed to be 261. So it's not perimeter, it's area. What's the area of a rectangle? Inside, good, but how do you get it? Length times width. So the area of this would be x times 3x plus 2, length times width, and that's supposed to equal 261
meters squared.
Cool. And in the equation, you don't worry about units because they just get in the way. They make you think there's extra variables.
Okay.
Don't write the units in the equation, write the units on your answer though. So what you end up with now in this problem, what tells you what you have to do to solve this? Because you have to distribute here, right? You can't just say x is 261 or 3x plus 2 is 261. The only number that works for it is if there was a what here? I can't say x equals 261 or 3x plus 2 equals 261. Do you remember that? I can't do that. That's what people are going to do. But it only works if this was a 0. Right? We talked about that. It's the only number that I know. If it equals 0, one of the things has to be 0. If it equals anything else, they could be anything, really. One of them could be anything, and the other one would be 261 divided by that. So I know I got to remultiply this out, and then I got to make this side 0. So we're going to move that over. And this is the other part of math that people don't get. Just because we learned this in a section and there was word problems or in another section, doesn't mean they're not going to happen at the same time. The word problem gets set up. The equation, how do you solve it? Any freaking method that works for that equation. Right? Word problems can use anything. Because the relationships could be anything. So here I've got this yummy looking thing. And what method do you use to try to do this? What do you have to do to solve this, to factor this? Yeah, you got to go there, but you can't go straight there. Because the stupid first number is a 3. So what method do I use? When the first number is not a 1, what do I have to do first? What's the first step? If I could, can I take a 3 out? No. Damn. If only I could divide by 3, that'd be awesome. Can't. Scheiße. So what do I do? Yes, good. 3 times negative 261. Aw. I should have looked here.
783.
Yep, negative 783. The reason I'm not being mean because I'm an asshole, I'm being mean because remember, that's a gross number. I agree with you. Good Lord, I don't want to try to factor that number in a lot of different ways. Bless you, bless you. Right? I'm with you on that. I totally am with you. That's why I wouldn't do it. Shit, no, I'm not going to do that. Screw that. I'm going to find 2 numbers that
Make up.
add 2 and then check to see if they multiply me negative 783. Right? Now, the fact that this is negative tells me the 2 numbers, are they going to be the same sign? No. They're going to multiply by negative. They're going to be different signs, which is why they're allowed to add to be 2, because they really will subtract to be 2, because one of them is going to be negative. Are you guys with me? That's the whole thing I showed you. My colleagues are like, you let them add first with this shit? And I'm like, calm down. I don't understand. It's so much easier. I don't want to factor that stupid thing. But can you give me 2 numbers that are 2 apart? Give me 2 numbers that are 2 apart.
3 and 5.
3 and 5 is great. I mean, 3 times 5 is 15. That's a little bit small. We want to be there.
Oh.
But that's not a bad... If it was negative 3 and 5, it would add to be 2. But does it also do the other thing it's supposed to do? No. Which is fine, Jim. I'm not saying... That's a good place to start. You go, holy shit, it's way too small, so now I'm just going to make my numbers bigger. So give me something else. 2 numbers that add to be 2. Or 2 apart, right? Because one of them's negative. Like, let me just do it. What about negative 18 and 20? Well, what's negative 8, right? Negative 18 plus 20 is 2. But what's negative 18 times 20? Negative 360. We're getting closer. We're like halfway there in a way, right? So then I would think maybe to make this negative 28 and 30. You guys see what I'm saying? Now that's probably too far. Like, I know it's too far. Just a little bit too far, I think. Right? Is it too far?
Negative 840.
840.
Negative.
But you guys...
Negative 27 and 29.
There you go. But see, I'm really close. Now, I went a little too far, so I would dial it back a step. This is not difficult at all. It isn't. You have to understand how to kind of set this up, what the reasoning is. By every set of numbers I write down, I have to add to be 2, so that I have that condition met. And then I'm just checking, do I have the other condition met? No. Negative 27, 29? Yes. I like it. So, because how do you factor a trinomial with the number that's not 1 out here? You need 2 numbers that multiply to be this and add to be this. They don't have to do either one of those first. They just have to end up doing both. So make one of them true, and then make a bunch of them until you get the other one to be true also. That's what you normally do. You normally make a bunch of factors of this, and then you check to see if they add to be this. I'm just saying, why not do it the other way? For these ugly freaking numbers I don't want to factor. Alright, so what do I do with these 2 numbers? You guys are like, I'll tell you what you can do with this. 3x squared, and you break up the 2x minus 27x. I like it.
X minus 260.
So now I figured out how to break 2 up. And now I got how many terms so that I know I can group. Right? Grouping is relatively easy. Even with ugly ass numbers like this, because the problem tells you what to do. I desperately want you to see all these little things I'm telling you. The first piece is easy to factor, right? What comes down to both of these? 3, x. So you're left with x minus 9. Now I know I got to be left with an x. So what do I have to take out of here, even though you don't believe it's true? I have to take out? No. I want there to be an x here, right? And maybe stop here. Do you guys understand why that's got to be an x? Because what's the only way I can do the last step is if this is the same as this. Now see, that's the key. The problem tells you what to do. If you feel pretty good about this one, and you don't have a clue, well, yeah, you do. So I have to take out a 29. I have to. And then you go 261 divided by 29, and that is?
27. Negative 27.
261 divided by 29
Oh, wait.
9.
is minus 9.
Oh, sure.
Yeah.
Wrong word. That is the wrong word.
So part of the process of grouping, bless you, tells you how to do the grouping. Students desperately want this kind of thing, and then when I show people this, they kind of forget it. I'm like, that's the thing I would latch on to. Holy shit, if I know this, it tells me how to do this, no matter how ugly it is. That sounds awesome. Yeah. And then, of course, the last step here is, in the factoring, yeah.
3x plus 29.
So either x is
9.
9, or x is some gross negative number, and can x be a negative number? Mathematically it can be. Physically, no. Right? I want you to build that shed that is negative length on one side. What kind of material is that? It's like
Dark
advanced.
matter.
Exactly. Dark matter, something from a different dimension. Some black hole shit, I don't know. Right? Don't get too near your shed. Don't put anything in there. You'll never get it back out. So now, x, so that can't be that. So mathematically, it's perfectly fine. But since this problem models a physical, real-world thing, I can't use that number. So it doesn't mean that math gave up on it or something. It's the real world. I can't use negative side lengths. So x is 9. So then this side, 9 what?
Meter squared.
Meters. Careful. Meter squared here because it was meter times meter.
Yeah.
And then this side's got to be, of course,
3.
29.
Yeah.
And see how that number 29 pops up a few times? That happens a lot with this kind of thing. Holy shit. And then how do you check it, of course? 9 times 29 better be 261, thank God. It is. Shit. Alright. So I want you to realize this problem had a lot of parts. Every part is relatively simple. Students that have a lot of trouble with math can't see the parts. They just think they are supposed to see the whole damn thing at once. That's insanity. You're never going to pass that shit if you think that's what math is. Math is all about breaking it down into little easy parts. First part, what are the English words for what's going on? That's a step that people skip all the time. It's like, holy crap, that's the easy step. Do that step. And then go blah, blah, blah. And then the rest of the steps.
All the rest.
All the rest. I'm not going to redo the steps we just did.
How to draw an owl. Draw 2 circles. Then draw the rest of the owl.
We'll see what happens to you. Okay.
I have a question for the class, for 1F.
Oh, yeah.
For,
Oh, yeah. So that's the kind of thing we need to do, because that's the kind of thing that's really easy to have leak out your brain. So just remind me, what's the square root of 25?
5.
5. What's the square root of 50? Shit, I don't know. Give me an estimate. 50 is a little bigger than some nice number with square roots.
7.
Yeah, 50 is a little bigger than 49, so the square root of 50 is a little bit bigger than the square root of 49. I know it's a little bit bigger than 7. But that's not good enough, right? So, I don't know if you guys remember, this is very related to, what's 6 divided by 3? 2. What's 8 divided by 3? Nothing pretty. But 8 has a 6 in it, which is divisible by, now stay with me. Stay with me, sir. 8 has a 6 in it, which is divisible by 3. And it's got an extra 2 that has to stay on top of the 3. That's, of course, what that remainder is. It's the extra on top of that doesn't make it go in evenly. So the same idea with this, except multiplicatively, because roots are all about factors. So what's 50 got in it that I can take the square root of? No. It's got to be based on multiplication. This was based on addition because division is the opposite of multiplication, which is based on addition. Holy shit. This has got to be based on multiplication. So what's 50 got in it factor-wise? 25. Times the extra. This is just like this was, it's got a 6 in it plus the extra. It's got a 25 in it times the extra. I desperately want somebody to see the analogy here. They're exactly the same, to be honest. If you don't quite get it, well, at least try to remember this process. Then I can do square root of 25 times square root of 2, just like I did 6 divided by 3 plus 2 divided by 3. Square root of the thing I can do times square root of the thing I can't do. I do the thing I can do. And then I leave the thing I can't do, the same way I left that. Or, that I could do, but the answer is gross. Right? Yes. 2/3 is 0.6. Square root of 2 is 1.414, blah, 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 blah. Same kind of feel to both of those. Maybe not. Maybe so. So, what do I do with this problem then? Because there's more to this problem, right? I like it, Jackie's line. That ain't that problem. What are you talking about? But that's a part of it, right? So I got square root of 18 minus twice square root of 50 plus 3 rad 2. Well, we did the middle one already. This is minus 2 times 5 times rad 2. Now, how do I do the first one? What does 18 have in it as a factor that's square rootable? 9. So 18 is 9 times 2. What's the square root of 9? 3. What's the square root of 2? I don't freaking know.
Oh, that's crazy. I see.
Right? And then you got minus.
So now everything has 2.
Yeah, exactly. Minus 10, rad 2. Does this always happen? No, but whatever like terms you have, and here we just happen to have everything like terms, so I can put everything together. If there's a number already out there, it's multiplying, so it would multiply by whatever you bring out. So 3 of these, plus 3 of these is 6 of them, minus 10 of them is negative 4. Negative 4 of So now it's just like 3x minus 10x plus 3x. 3 something I don't know minus 10 something I don't know plus 3 something I don't know is negative 4 something I don't know. Just collecting all the crap I don't know.
Want to tell you the answer?
Yeah, that's it. Yeah. There's nothing else we can do with that. So see how, one way you could look at this, Ronald, like you said, one way I could look at this is look at that as a clue.
Yes.
I'm going to try to break this up as 2 times something. Because I know I want there to be like terms left over if possible. 2 times 9, 2 times 25, hey. So you can use something that's already done as a clue.
So, alright, so we don't have the same, like...
Yeah, so,
for all of these.
here, you ready? So we had square root of, what you got, Jeff? I don't know, man. 20 minus 2 square root of 28 plus 5 square root of 5. based on Ronald's question, you should know what to expect to happen. Yeah, try this one out. So 3 somethings minus 10 is not makes it 4. 3 of these minus 10 of these is. So what's yeah. So it's just like 3x minus 10x plus 3x. So you're just combining the coefficients now, yeah. Alright, let me catch up to you guys. What does 20 have in it?
16.
That's square rootable. Nope. 16 times what is 20? So remember, it's square roots. They're based on exponents, which are based on multiplication.
4 is the one that gets to 16. Right?
Oh, I see.
Right.
But we're thinking, what factor does 20 have in it?
Oh, okay.
That is square rootable.
Okay.
4. And now the other way to look at it is, can I do anything with this one? No. So I'm going to look at 5 as a clue. 5 goes into 20 4 times. 5 goes into 20. No, it don't. All right. So that's not going to be like terms, but you still should simplify it. So this is square root of 4 times square root of 5. Is that cool? Because that makes square root of 20. Now what comes out of here? Well,
14, right?
but see, 2 and 14, neither one of those are square rootable. So you think about square rootable numbers. Divided by 4, divided by 9, divided by 16. Divided by numbers that you know are going to work. Well, what's 28 divided by 4? 7. So I end up with 2 square root of 5s minus 2 times 2. So 4 square root of 7 plus 5 square root of 5. What's the only like terms up there? The square root of 5s. Yeah, so I get 2 of them plus 5 of them is 7 of them minus 4 of those. So they weren't all like terms, so you just combine what you can. Very good question. I can still use this as a clue. It just might not work for everybody, but it might work for some.
What do you do with the minus 2?
Oh, this is minus 2 and times. What's square root of 4? Square root of 4 is? 2. 2 times 2 is 4. Isn't this? This is 2 times this. So it's 2 times the square root of 4 times the square root of 7. Square root of 4 is 2. 2 times 2 is 4. Any number that's already out here is going to multiply by the number that you end up getting out of it. Because it's multiplication there in that term.
So basically, anytime we have 3 numbers, 2 of them are going to have like terms.
No. Look, there were 3 numbers. All 3 of them had like terms. You see what I mean?
Right.
So don't go in expecting anything. You know what I'm saying? I mean, almost always, if I'm going to make a problem, I'm going to have at least a couple like terms you can put together. If not all of them, right? So, but don't expect to be able to put them all together. You just do it, and then you just see who's like terms. I like it. Don't think you've done something wrong because this didn't end up with a 5 in it. Doesn't mean you did something wrong. It might, but it doesn't mean it, for sure.
And then 5 just cancel.
What do you mean? 2 of these
5 is going
plus 5 of these is
7.
7 of these. They were like terms, so I just put them together. Yeah. They didn't cancel, they just went together with another part of it. So this is exactly the same as 2x minus 4y plus 5x. Because I don't know any of these, but I know that this unknown and that unknown are the same. So what would this be? This would be 7x minus 4y, which is basically the form we got. 7 something minus 4 something else. Same thing. I like it.
Is E just like terms?
Totally.
And then,
E is the problem where people make a mistake, they start distributing. But that's a minus in the middle. Don't make that problem that disgusting, right? It's a minus in the middle, not a time. So don't start foiling this stuff out. That's crazy. Go ahead, Lynn. What's
E looks.
Oh, yeah. Well, the big thing behind B is, what do negative x1s mean?
They go on the bottom. Yeah, they flip.
Or if it's on the bottom, it's going to go up top. So that's the first thing I would look for is anything that has a negative power, I'm going to move it to the other side. The mistake people make is somehow they end up with these canceling, but are these the same?
Yes.
Are these the same? Are these the same?
No.
No. So how could they cancel? They can't. They're not the same. Only the like things cancel top and bottom. What are your negative powers? What's being raised to a negative power?
Those. No.
Yeah, this thing and this thing. So negative powers being flipped, so wherever they are, they're going to go to the other place. So for some reason, people have this 24 come down too. But what power is 24 raised to? An understood 1. It's not being raised to a negative power. It's not attached to this like it can't come apart from each other. Of course they can. So I can rewrite this as 24. Those 7 y's are still there, and those 7 y's come up over 15. Those 7 x's are still there, and those 6 x's come down. Now this is a lot easier. I mean, 24 over 15. Right? If you can't reduce that, then you should take this class over. Right? How do you reduce 24 over 15?
8 over 5.
Yeah, 8 over 5. How many y's do I have up here now?
14.
14. And how many x's?
13.
13. So really, the key thing that made that problem easy is moving anything with a negative power first. And then you got rid of the negatives. That's a big place people make mistakes. Get rid of the negatives first, and then the rest should be a lot easier. Yeah.
Number 4A.
Oh, yeah. All right. Let me make sure you know the first step to take, and then I'll let you guys do it. I'm doing too many of these for you. Let's see. So somebody remind me, the fact of this was the first step. There's 3 terms. So you know it's not grouping, you know it's not squares or whatever, right? There's no GCF, right? No GCF. They don't all have something in common. Somehow somebody manages to take out a couple X's or something. What would that guy think about that? You know, what the hell? And this guy's like, X's, what are you talking about?
I don't know. No, like terms. You're not.
No like term, so it's not it's not a simplification problem, it's a factoring problem. So I'm not looking for like terms necessarily. So it's 3 terms. I know I want to make it become what? Christine, you did this earlier. I know I want to make it become bam bam eventually, right? I can't just go to bam bam though, because the first number is not 1. Right? If the first number is a 1, that'd be a much easier problem. Specifically, that wouldn't work though, but it will. In general, if the first number is a 1, it's a much easier step. But what do I do since that's not a 1? What do I do?
Just a 6.
Yeah. 5 times negative 6. It's negative 30. So I need.
Not hurrying, yeah.
Two numbers that are.
Yeah, two numbers that.
10,
Yeah, then multiply to be negative 30. Add to be negative 7. So whenever you have three terms, you know you're eventually going to have to do what we're doing right now. But when the first number is not a 1, you got to get the number you're working with by multiplying those together. So yeah, 10 and 3, which one's negative? Yeah, the bigger one, so the answer comes out negative. And now we'll finish that up. Bless you.
So do we?
I mean, the next mistake people make is they forget the middle term has got an X and a Z in it, so that
Do you
better
split
still
the
be
X
true.
and the Z?
No.
You need to keep both. That's what I'm about to say.
I need to make 7xz's, right? How do I do it? I can have negative 10xz's
And then-
plus 3xz's. Whatever's there stays there on both. That's the only way it could become this. If one was X and one was Z, they're not even like terms. There's no way they can come back together.
For 3A, I got lost. How many X's?
Okay. You started trying to move stuff a little too early. Okay, you're good, though. That should work out. Not undefined. Keep going, get your x's together. So subtract 2x.
But it'll be negative.
Yeah, that'd be 0 equals 17. That's never true. So what's the answer? There is no answer. There's no solution.
So,
For 6, I know how to do it, but I just remember job, know how to do it.
Oh, let's hold on. We'll do that in the next.
Oh, okay.
Yeah.
it's like that.
So what we got here? We have 5x squared. Whatever this is,
He said not
these have to have them, so they're like terms. So I'm going to put the negative one first because I got an option. And now I can group. Comes out of these two.
5X. And then
X
X.
minus 2C. 3Z.
Yeah, so you know you want to end it with an x. So you take everything out that's not the x. X minus 2z. Thank God.
That's the way it is.
So then the last step.
X minus 2C.
Square, I mean, constant, it's
How do you check yourself? Check yourself. What do you do? You remultiply it. Yeah. Right? Same way you would check yourself. I said factor 316, and you get this long list of numbers. How do you check to make sure you're right? You multiply them all back together. Make sure they're actually 360. Multiply these back together. Make sure they're actually this. If you have time. So you can do it.
Just a quick question about 3A.
Oh, yeah.
Getting
Yeah.
all these together.
Yep.
X's. I get 0.
Good.
So then it's, what is it?
So remember,
Or something?
yeah, before we do number 6,
I just what's the, how do you?
if you solve an equation, if you start with an equation, x plus blah blah equals blah blah, and you solve it and you get 7 equals 8. You've not just proven that 7 equals 8, right? This is the only way math can tell you something. This is math's attempt to say, okay, if you can write that shit down, then 7 equals 8. Nah. So what math is saying is, when this is true, then this equation is true. Well, when is this true? Never. So the equation is never true. So what's the solution? No solution. So please, dear God, if the x's want to go away, let them.
Okay.
It's nice. Now, if you end up, if you do blah, 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 and you get 10 equals 10, when is this true?
Always.
Always. So what's the answer? All real numbers. Don't circle the 10 equals 10. Right? I'm a little worried about it.
It's like
10 equals 10. Amazing. No. You have to interpret what that means. right? Submit that to Drew.
Oh, yeah.
I've discovered it too. It sounds like a lot of things. Yeah. So, I got a question about number 6.
Yeah, I know that we've done it before, but like my mind is not.
Well, yeah, I mean that's everything. You got to go back and
Yeah.
right. You're like, I remember doing that.
Oh yeah, that's what I was like, yeah, it's on my list.
So we'll do part A, and then I'll let you guys do that. So the basic idea of probability. What's going to be on the bottom of a probability? The total. I like it. So the very first thing to do in this is to triple check yourself when you add those numbers together. Because if you get that wrong, they're all basically wrong. I'm not going to go crazy and take all the points off, but just think a minute, make sure you add it up right. Because that answer you're about to give, when you add them all up, it's going to be in every single answer. So you got to make sure it's right. So how many total people do I have?
47.
Yeah, 27, 47. 47 total. So I want to pick. So let me just start with this. Let's not even do part A. Just tell me what's probably that there's a student that I picked that's a member of the Green Party.
2 over 40.
Yeah, there's 2 that match what I'm looking for out of 47 total things that could have happened. I like it. So now for part A, it says not just that. It says what's probably going to green, somebody from the Green Party, and then somebody from the Democratic Party. All right, who remembers what "and" means? This is this whole thing about. I'm walking down, somebody slapping me, and somebody else slapping me. Remember, it's how often will it happen at the same time? You multiply. If I added, it wouldn't make any sense. Because, so if I put a lock and another lock and another lock, and there's a 1% chance that somebody's going to get through those locks, I don't want 3 locks to make it a 3% chance now. 3 times as likely. So if I put 100 locks on there, it's like, just open the door. No, it doesn't make any sense. So multiplying numbers smaller than 1 makes the result even smaller. So there's a 1% chance there, and 1% of those times the other one gets unlocked. Of means multiply. Right? So and in probability, it's based on that, so it means multiply. What means add? Or. Right? That's the nice bouncer. You or you or you, so I'm just adding you all together. Everybody come in. It's just increasing the number of things that's included. And decreases the number of things that are included. So it's probably the first person is Green Party member. We just figured it out 2 out of 47. Then I throw them back in the mix, right? That's what with replacement means. And multiply. Democrat now.
23 out of 47.
23 out of 47. Equals whatever the hell that is.
46 out of 47.
No.
No.
It's .02.
It would be 46 out of 47 squared, right?
Times 47.
Careful. Yeah. See. Otherwise, you get numbers that are bigger than 1, which is freaky. It means it's so likely going to happen. It's going to happen even without you doing anything. Pop. Whoa. So that's part 1. Part 2A is without replacement. So the only thing that changes. The first one being a green is still 2 out of 47, but then we tell them to get the hell out of there. Go away. I don't know what green. Get out. I don't know if you guys know the Green Party. We make them go. We let them go to lunch. Let's be nice. We go ahead to lunch, and the rest of the people are in the room. So what's different now? How many Democrats are there? There's still 23.
Over 46.
Beautiful. So that's what the without replacement does, is it changes the bottom on any successive fractions. Now, people make the mistake of putting a 45 here. Why do you think somebody might do that? But I didn't pick 2 people, right? The 2 is the options to get that kind of person. How many people have I picked at this stage? 1. So it can only go down by 1 at a time.
Unless it says otherwise, unless it says you're thinking 2 or 3
Well, so if I picked a third person, it would be times something out of 45. So each time you do it, it goes down by 1. Yes?
If it's the same, like how it's double 0 or double O, wouldn't you knock down the second O? Or the same thing?
Oh, yeah. Well, for the first O and then O, the bottoms, of course, stay the same.
Yeah.
But for the second O and then O, not only does the bottom change, but so does the top, because you've picked an O first. Why did this top not change? Because I picked a green. So, of course, there's still all the Democrats.
Okay.
I like it. So probability, notice probability is all built off of counting. It's really all counting the options that could happen. So of course if I'm losing an option, that's going to show up in the math. I lost an option.
I'm still not understanding. Hey, like, what would the answer be for 47 times 47 squared?
It's
No. So if you did this by hand, I mean this would be 46 over 47 squared.
Okay.
You know, whatever the hell 47 squared is.
Should be no matter.
So then and you just do this in the calculator, Mike. Yeah.
Yeah.
I'm not going to make you do this long division by 47 squared.
0.020.
8.
I have a question for number 5. I still don't know how to make this slope.
So what's the most basic equation for a line? What's the most basic equation for a line? Not the one we did with the correlation thing. That was the second level.
Y equals mx plus b.
MX equals B. Why do we make such a big deal out of this? Because what's freaky about this should be freaky. What's freaky about this is if I solve any linear equation for y, these things just fall into place. I just see them. I don't have to do any work. I can just pick them off. Well, what's M stand for? Slope, right? M for slope. I got 11. Again, it comes from a French word. So that's slope. And this, of course, is the y-intercept. So if I ask you to find the slope and the y-intercept for some line, the quickest way to do that is to get y by itself. Because then everything falls into place. So if I have this equation, 5x minus 2y equals 12, and I say, what's the slope and the y-intercept?